Hello everyone, today I will be presenting homework problems from Photoelectric Effect. For number 7, it said light with a wavelength of 95 nanometers shines on selenium surface, which has the walk function of 549 electron volts. The ejected electrons have some kind of kinetic energy. Determine the maximum speed with which electrons are ejected. So the formula we use for this problem is kinetic energy of photon electrons equals to energy of photons minus the energy of the walk functions. So to find the energy of photon is equal to h times velocity, which can be translated to h times the speed of light over the wavelength, which will be 6.63 times 10 to the power of negative 34 joules times second, and time with the speed of light, which is 3 times 10 to the power of 8 meter per second. And the wavelength is 95 nanometer, but we will convert it to meter, which will be 9.5 times 10 to the power of 8 meters. And then we subtract this with the energy of the walk function, which is 5.9 electron volts times 1.6 times 10 to the power of negative 19 joule. And the answer should be 1.15 times 10 to the power of negative 18 joule. But for this problem, it's asking for the velocity of the photoelectrons. So we change the formula of E into 1 over 2 mass V squared. And for the mass of the photoelectron, we know it's 9.11 times 10 to the power of negative 31 kilogram. And then we multiply 2 to both sides and divide both sides by 9.11 times 10 to the power of negative 13 kilogram, and then we square root everything, and the answer you should get is 1.6 times 10 to the power of 6 meter per second. For 8a, the number 8 says sunlight holds visible wavelengths range from 380 nanometers to 750 nanometers is incident on the sodium surface. The walk function for sodium is 2.28 electron volts. For part A, it says find the maximum kinetic energy of the four electrons emitted from the surface. So then again, we use the same step for number 7, which is this formula. But for we change the wavelength because it will give us a different wavelength, and then we convert it to meter. And for the walk function, is 2.28 electron volts times 1.6 times 10 to the power of negative 19 joule, and the kinetic energy should be 1.58 times 10 to the power of negative 19 joule. For a B, it asks the range of wavelengths that will cause photoelectrons to be emitted. So we use the formula of energy of the walk function equals to h times the speed of light over the wavelength. But then we will change it to wavelength equal to h times the speed of light over energy of the walk function, which will be 6.63 times 10 to the negative 34 joules times second, times the speed of light, which is this, and then under it, and then divide by the 2.28 electron volts times 1.6 times 10 to the power of negative 19 joule. And the wavelength you should get is 5.45 times 10 to the power of negative 7 meters. But this problem asking us to convert to nanometers. So you get this answer and uh, multiply it to the 10 to the power of 9 nanometers, and the answer you should get is 545 nanometers. So this wavelength, in order to push the photoelectrons out of the metals. Thank you for watching this video.